In this video, we're going to do some guided exam question practice on the 2019 science question that came up on calculate speed. Now, this one is a pretty straightforward little graph. Most of you, especially doing higher level maths, even ordinary level maths, you'll have done lots of questions like this. It's just reading a graph, doing a little calculation on speed. Nothing too complicated. Okay, let's take a look at it. Okay, so what does it say? It says the graph below represents the journey of a cyclist. Okay, a reminder, this is a 15-mark question, so we've got about 5 minutes for this. Okay, so we're showing the journey of a cyclist, and we've got different points along the way. Let's just look at the axis first of all. On the y-axis, we've got distance increasing from 0 up to 250 meters, and on the time axis, we've got time in seconds increasing from 0 up to 140 seconds. On the graph, there are 5 different letters shown as different stages of the journey, A, B, C, D, and E, and you might be asked about that, okay, about some of those letters. Okay, so let's just go ahead and look at part A. What does it say? It says name, so we just need a name. Name an instrument. Instrument just means piece of equipment. Name a piece of equipment or an instrument that could be used to measure the time taken for the journey. All right, literally name something that could be used to measure time. Okay, so go ahead. I'm going to write this down. If you're working exam papers, write it in. If you're working in your copy, let's go ahead and write. It's question 7A, and we're naming an instrument. Okay, so what's the name of the instrument measuring time? Pause the video and write down the answer now. All right, so what you should have written there is a stopwatch or a timer. That's what we use in science. Anytime we do an experiment where we need to measure time, we're going to use a stopwatch or a timer. Either of those is going to be fine. Next one says to calculate the average speed. So calculate, we're going to have to do a little calculation, the average speed of a cyclist as he traveled from point A to point B. All right, so we just want to know from here to here, what is the speed of the cyclist. Now, what do we know already? We know the distance that he traveled and we know the time. Okay. So thinking about what is speed, okay? So if you know the formula for this, then go ahead and write it down. Speed equals, what is the formula? Go ahead and write down the formula for speed. Do that now. Okay, so if you don't know that already, at this stage, what you can do is you can pause the video and go check your log tables. If you have log tables, do that now. Okay, so if you couldn't find it, here is the page in the log tables where you might find it. So pause the video, see can you find it. If you can, write it down. Okay, hopefully you found it here. Average speed equals distance divided by time. Okay, so I'm going to go back to the other screen now. Give me a second. Okay, so we've got speed equals distance over, which means divided by time. So what we need to do is calculate the distance that they travel between A and B and how much time that took. So you guys should be well able to do this now. Pause the video and finish this off. If you didn't already do that now. Okay, so the distance that we did is we went from 0 up to, well, what's the distance at B? The distance at B is 100. We went from 0 up to 100. Okay, so, and that's meters. So it's 100 meters. And we're dividing by, well, how much time did that take? So again, we're looking here. It took 40 seconds. So 100 meters in 40 seconds. Now you've got a sum to do. All right, so you're going to pause the video and go ahead and figure that out. All right, what you should have got equals 2.5. When you did that on a calculator, 100 divided by 40, you should have got 2.5. Now, at this stage, you might not have included a unit, okay? So hopefully, if you look back at your sum, you can see what the unit is going to be. So pause the video and write down the unit. Okay, so what we're doing here is we're dividing 100 by 40. We're dividing one number by another number, but we're also dividing the top unit by the bottom unit, which gives us this, meters per second, meters over seconds, which is what's here, look. So meters per second is the unit, 2.5 meters per second. All right, next bit. Describe. Okay, so use words to describe the cyclist's motion between points B and C of his journey. Right, let's look at points B and C. So before I give you any help, I'm going to pause the video and see, can you guys write that down by yourself? I'm going to zoom out so you can see the question and the graph together. So pause the video and see, can you describe the motion? So that's what I want you to do. I want you to describe the motion between B and C. Pause the video and write down the answer. Okay, so here's a bit of help if you weren't sure. So from B to C, what was happening to the distance he was traveling? Okay, so hopefully you can see, well, the distance did not go up. Look, the graph is flat. He did not go anywhere. He stayed at 100 meters. Now he was stationary for 20 seconds, but that doesn't really matter how long he was there for in terms of speed. He wasn't going anywhere. So describing his motion. So go ahead, pause the video and finish describing his motion. Okay, so what you should have said here is that he's not moving or he's stopped. He is stopped. He might be having a rest. He might be having a drink. He's stopped. His speed is 0. Speed is 0. He's not doing anything. He's not going anywhere. So you should have said something like that he's stopped or he's not moving. All right, let's look at D. Sorry. The cyclist's speed as he traveled from point A to point B was less than his speed as he traveled from point C to point D. Is that true? Well, let's look at the graph. So they're saying that the speed from A to B was less than the speed from C to D. What evidence is there from the graph that this is true? So again, what we're going to do here is we're going to write down here evidence. We're looking at the graph and using some evidence to support the idea that the speed at C to D was faster than the speed from A to B. Okay, so if you're able to do that by yourself, pause the video and do it now. Okay, if you weren't able to do this, well, then I'm going to give you some help. What we want to know is when we're looking at speed, speed is really shown to us by how quickly is the graph increasing. So let's look here, compare the slope from A to B with the slope from C to D. If you notice any real difference here, that's going to help you. That's a piece of evidence that's going to help you to say whether this is true or not. Okay, so pause the video and talk about that now. So what piece of evidence proves this? Well, we would say from A to B, the graph is less steep. That's the word we want to use to say how quickly it's going up. Is less steep or has a smaller slope than C to D. So the one with the steeper slope is where the cyclist is changing their motion the quickest. So that means that speed there is faster than there. Okay, so it's going further faster here than he is here. So speed from C to D, because it's steeper, that means he's going faster. Describe what the cyclist did at the point D. So at the point D, what does the cyclist do? So once he got to here, what happened? Okay. All right. So again, what we want to do is we want to pause the video and figure out what happened. Now, remember, this is the distance he was away from a certain point. What happened when he got to D? Okay. Pause the video and write down, describe what happened. So describe is what you're asked to do. We got to D. All right, so hopefully you might have been able to do this by yourself. Okay, now if you weren't, I'm going to try and give you some help. Here he started at the point A. As he went, he got further away from A. Look, from A, going from A to B, he's now further away from where he started. He's 100 meters from when he started. It didn't change then, but then he went again and he got further away from when he started. He was now nearly 250 meters from when he started. But after D, he started getting closer back to where he started, all the way back to E when he was back where he started. So he's now 0 meters away from where he started. So he's back where he started. So what did he do at D to get it back to where he started? So if you didn't figure that one out yourself, or if you made a mistake, now I want you to pause the video and fix this. Okay, well, it's quite simple, but it might have been a tricky one to read. What he did is he turned around. He turned back and he started coming back the way he came. He turned back / or he returned. That's what he did. Okay, now some people might have said he slowed down or he stopped, but essentially what he's doing here is he's reversing what he's done. Here he was going away, and now he's coming back to where he was. Okay, now the reason why it's over here is because, well, this is showing the time, so the time has to keep increasing, but his distance away from where he started, he comes back to 0. So he's back where he began. All right, so again, well done if you got 12 on that one. Well done. If you got 15, then that's excellent, but that last one was a little bit tricky. Well, hopefully after seeing something like that, we'll be able to recognize it in the future. All right, that's it, guys. We'll see you in the next one.